Hello, my name is Augusto Perez de Andrade. I'm a mastering student oriented by Dr. Liliane Ventura here at the Optical Instrumentation Lab, University of São Paulo, Brazil. Today, I would like to present to you my ongoing research, contribution of different sunglasses frames to the protection against ultraviolet radiation, a suggestion of adaptation for the current standards. It's important to start talking about ABNT NBR ISO 12312, one from 2018. That's the current Brazilian sunglasses standards and is a mirrored version from the European model. The regulamentations are incompatible with the sun intensity of a tropical country such as Brazil and is limited to said spectroscopic conditions of the lens, such as transmittance in function of the ultraviolet type A and B protection. In order to adapt the current standards, the Optical Instrumentation Laboratory runs research on different areas involving sunglasses protection. My research focuses on include the different geometries of sunglasses frames as a parcel into the calculation of a new protection factor. To achieve this goal, an electronic system was developed to control a range of high-power ultraviolet LEDs that illuminates the internal area of a spherical environment with a mannequin at the center. Two photodiode sensors positioned at the eyes of the mannequin are also connected to the main embedded system to obtain the analog digital converted readings related to the light intensity. Last but not least, the instruments are connected to a graphical user interface responsible to run the commands. The methods adopted to obtain the results sets three different tests that runs in sequence. The dark test runs with LEDs turned off and no sunglasses and is responsible to get the offset sensors readings. In sequence, the calibration test runs with LEDs at maximum intensity and no sunglasses to obtain the corrected sensors readings considering the offset measurements. And with these values, we can calculate the calibration ratio between sensors. The final protection test runs with the LEDs at same intensity and sunglasses blocking the eye with the primary sensor, so we can collect the light portion that reaches the eye. And these countings are already calibrated from reference sensor. The primary results was obtained considering the two extreme conditions, full exposure and full protection of the eye. We can see that not only the two sensors readings are approximately equal in the calibration test, but the results are also current, that is, 0% for the full exposure and 100% for the full protection. Once we get the results, it's possible to say that we already can put different sunglasses frames into the system to obtain the protection associated to the light that reaches the eye. Nonetheless, recent experiments without sunglasses and different LED intensities shows that the interval between the two extremes doesn't have a linear behavior. The curves of sensors readings and calibration radio in function of LED's intensity shows that the low power of light scattered are not sufficient to get the measurements into a linear region, as we can see that the calibration ratio that should be constant is still into a transient state. That can also be explained by inappropriate electronics components that should operate with low current applications, such as our project. Finally, although the system can operate well into the 0% and 100% conditions, there is still work to do in the interval between these two. The activities already in progress includes increase the light intensity that reaches the eye by using more LEDs, or even reduce the spherical environment. The electronic parts are also being revised to eliminate the nonlinearity behavior. Once the fixes has been made, we expected to get the results of protection associated to different sunglasses frames geometries. I would like to end this presentation thanking the listeners and the foundations, CAPES and FAPESP for the funds required to reach the present results.